I'm gonna start with the second one of these. And before you start, right, before you start graphing a piecewise function, I would look at the functions that you've been given, right? And just say, so for example, for part A, I would look at this and I would say, okay, I have a linear function, a square root function. That gives me sort of an idea of how things are going to look. Here I've got an absolute value function, and then a square root function, okay? So we're going to graph the first one. Now, when it comes to absolute values or parabolas, you want to have an idea of how it's going to look on its own without the whole piecewise business, right? So here, absolute value of x plus 2, what does that look like? Like, where is it? Yes, it looks like the v. To the left, 2 units. So if this was not a piecewise function, right, if it was just that we were graphing, would it look like that? Yeah. Okay, so I try to visualize that before, then, so I have a good idea of what it's going to look like, okay? Because that's what it looks like, right? But this is cutting, it's going to get cut off at 0. So do you see how I have a little bit of that v and then that one, right? You see that? So I want to visualize that a little bit before. So here's what we're going to do. X and then y equals absolute value x plus 2. What's the first point I want to plug in there? 0. And I get y is 2. And that's a closed circle. I'm sorry, open circle. I meant open. I put an open circle, but I said closed. Yeah.
I'm kind of confused on when it's a horizontal shift. If it's plus 2, why do we go to negative?
Because you take the stuff inside and you set it equal to 0. When you solve for x, x is negative 2, meaning it's shifted to the left.
Well,
yeah.
If there was like a coefficient in front of that, how would that? Because if you do that in the parent function, the slopes will be the same because it would just be like instead of 1
but then,
1, it would be like 2 over 2.
Right, but then if you go over 1, instead of going up 1, you would go over up. You would go up 1 times the coefficient.
Oh, okay.
Yeah, okay. So we knew that the vertex of this was going to be here. And look, I already have that point. And then here, I'm going to do like a symmetric point and there. Okay? So that's number 1. Number 2, I have y equals absolute value x minus 2. And I know that that's an absolute value graph shifted where? Down, right? It's shifted down because it's absolute value x minus 2. So the full-fledged graph of that would have looked like that. But right now, the first number I'm going to plug in is 0. And I get y equals negative 2. What else do I have to plug in here? A 2. And I get y equals 0. So negative 2 closed, or 0 and negative 2 closed. Open at 2, 0. Boom. Okay? That's all I need from that. Lastly, I have a square root function. I'm going to plug in a 2, and I'm going to get root 4 plus 2, which is 4. And that's an open circle. Next, I want to pick a value for x that's going to make the radicand a perfect square. So I don't want to choose 3 because then it'll be root 5. 7 is a good one because then I get root 9, which is 3 plus 2 is 5. 3 plus 2 is 5. So at 7, we're at 5. Yes?
Yeah.
Okay. That's how that looks. Okay? All right. Lastly, so we've done all these transformations. Next, we're going to do transformations with absolute value. What happens if there is an absolute value around the function or around the variable? Okay? Okay, so suppose you have an absolute value around the function. Can somebody tell me an appropriate function for that blue graph over here? F of x equals what would you say?
X squared minus 2.
X squared minus 2 works for me. Okay. Okay, now, do you see how you have some parts of the graph are positive because they're above the x-axis. Some parts of the graph are negative because they're below the x-axis. So here and here, f of x is greater than 0. Here, f of x is less than 0. Now, if I were to take f of x and put it in absolute values, that means f of x, or in other words, y, is no longer going to be negative, right? Because what does absolute value do? Whatever goes in there, it makes it positive. So this is going to make all the y values positive. So that's going to look like, you know, g of x is going to look like absolute value of x squared minus 2. So no matter what value goes in here, right, all the y values are going to now be positive. So the ones that were already positive will stay the same. But the part that was negative now has to be made positive. So for example, here, if y is negative 1, nope, now it's got to be positive 1. If y is negative 2, now it's got to be positive 2. Negative 1 has to be made positive 1. And when you graph that, look at what happens. You've got the reflection almost around the y-axis. Do you see that? Okay? So that's what happened. It used to be like this, but now each of the negative y values has now become the corresponding positive y value. Okay, so that's what putting the whole function in absolute value does. Now, what if you so what would be a good function here? What would be a good, an appropriate function for this one? F of x equals what? X minus 2 squared. Yep, that works, right? Because or it could be x minus 3 squared or x minus 5 squared or whatever, right? So now, what if for g of x, I did absolute value x minus 2 squared? Okay, so now, whatever x I put in here, that absolute value is first going to make it positive. Okay, that means I'm no longer going to have any more negative x values, correct? So all of these negative x values are going to be thrown away. But what's going to happen instead? So it used to be that, let's say, when x was negative 1, what would y have been here? At x equals negative 1, y would have been how much? 9, right? But now, if I put negative 1 in here, then first that switches it to x equals positive 1, and you get the same value as you would have gotten for positive 1. Do you see that? So, essentially, everything in the negative x's goes away, and in its place, you get a repetition of whatever was on the positive side here. Okay? So whatever was on the positive side, it gets mirrored over here.
But you're still getting negative x.
So yes.
Yeah, that's why I know.
Okay, but here's what happens. Look. Are you allowed to put in a negative value in here?
Yeah.
You are.
Yeah.
But for that negative value, you get the same y value as you would have for the positive x.
Right.
So if I put a negative 1 in here, the value I get is for the positive 1. Okay? All right? Okay, so here, Okay, so for this one here, I'm actually going to change this graph, this function, to something else. I'm actually gonna change it to y equals, I want it to be something we can see a little bit more easily. All right. So let's do y equals, or f of x equals, x minus 1 squared minus 2. Okay? All right, so we're going to use that graph to graph absolute value f of x and f of absolute value x. So let's first graph this original one. So there is a shift where for this one? To the right one and down 2. Right 1 down to here. Okay, so I go over 1, up 1. I go over 2, up 2. I'm sorry, up 4, you're right. 1, 2, 1, 2, 3, 4. Okay? Yes. Okay? Now, let me... All right, so this is y equals f of x. All right? Now, if I want to graph g, which is absolute value of f of x, what's going to change? Huh? Right. Anything that has a negative y coordinate has to flip upwards, right? So we're good until here and here, and then everything here has to flip up. So for example, the vertex was at negative 2, right? Y equals negative 2, and now it has to switch to y equals positive 2. Okay? And everything else flips around correspondingly. So that would be the corresponding graph. Okay? All right? So if I were to take away the previous one, this is how the new one will look. Okay?
So basically, like, if the absolute value x.
So now, for f of absolute value x, we're going to start with the same graph. So at negative 1, we're at negative 2, and then here, and here. Okay, boom. Okay, so that's what we had before. Okay, so now what's going to happen is, well, what is going to happen?
The part that's in the negative x section
Uh-huh.
will go away, and then it'll be like mirrored of the
Right.
positive.
So the part that's in the negative x will go away. So hang on, let me start over here. That's what we had before, right? Anything that has a negative x value will go away. And whatever's left on the positive x's is going to get mirrored over. So
Isn't it already a mirror though? Technically, like, is it just a parabola? Like,
right, but what you had before was just that red line. But now in its place, you're having the entire parabola get mirrored over.
oh, okay.
Okay? All right. So that takes care of this section.